This is 4.4 Exponential and Logarithmic Equations Part 2. We're actually picking back up right where we start looking at solving logarithmic equations. So in the first part, we looked at exponential equations and using what we know about logs and exponentials and their properties to solve those. And so now we're going to look at some logarithmic equations and use those use some of those properties to solve them. So on this first slide, we're going to use what we know about changing an equation that's in logarithmic form to exponential form to solve an equation. And so they show you the circle that we discussed. If I have this form right here, I can rewrite it in an exponential form and then go from there to solve. It does let you know in the steps below, the step 1, step 2, step 3 at the bottom of the slide, lets you know that if you have multiple logarithms, that you will condense it to a single logarithm. So sort of bringing in a lot of the concepts that we covered, how to condense was one of them, and so we'll be using that as well. Okay. So on this slide, we see a logarithmic equation. And so we're going to use what we know about expressing it as an exponential equation to solve this. So I take my base. That's my base, whether it's in logarithmic form or whether it's in exponential form. So when it's in exponential form, that's the big number, right? So base raised to 2 equals x. So that actually pulls the x out of that log so that we can solve for it, right? So 5 squared is 25, and that would be my answer. And then we can check this in our calculator. So I'll get my calculator out. And I'll do log. So to get to the log where my base is not a 10, remember that if I use this button right here, right, the log on, that's actually shows a log button on my calculator, it's going to give me a common log, which has a base of 10. But to get to that log that allows me to put in the base, I'll press math, so F4, and then you'll see log AB above F2. All right, so and we said that x was 25, and it shows me that, yes, x is 25 because it gives me that equal to. Also, something I didn't address back here, right here, it specifies that I have to check my proposed solution, right? Because you cannot have, notice where m is, right? So that's the number that we're taking the log of. That number has to be greater than 0. So once I get my answer, once I solve for m, right, and change it to exponential form and I get m, I have to make sure that that portion is greater than 0. So here I solve for x and it is greater than 0, so I'm good to go. So just keep that in mind. And it's not that x has to be greater than 0, but the entire value. So here, when we check it, we're going to check whatever we solve x for plus 20, is that greater than 0? So just remember that and don't get confused that it's the x that has to be greater than 0. All right, so using that same approach, we'll say, I'm going to write it a little bit bigger. Log base 2 of x plus 20 equals 2. So I'll say base raised to 2 equals x plus 20. So base of 2 raised to the second power equals x plus 20. So notice how it pulls that x out. So now we can solve for it. So 2 squared is 4. Subtract 20 from both sides. and I get x equals negative 16. So this is why you have to understand that it's not that x cannot be 16. It's that when I plug it back into the log, that value that we're taking the log of cannot be negative. When I plug that in, I would get log base 2 of positive 4 equals 2. And that's okay, right? Because that 4 is a positive. So my solution set would be negative 16. And we can check that on our calculator. And you can actually, put it in to the actual original, sorry, I keep pressing buttons, the actual original equation. So notice that I was about to put 4, but let's say I miscalculated that. So maybe I'll put in x as what I solved it for, and then whatever else was there. And it outputs 2, so that's correct. All right, solve the logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. That's just saying that if it makes that value that we're taking a log of negative, then we have to reject it. Okay, so I'll write this a little bit bigger. So remember, my goal is to get it in that basic logarithmic form, meaning that I want it in some form like this. So when I look at here, see, I have a natural log there. And remember that that's just log with a base of e, right? So I need to get rid of this 6 so that I can go ahead and convert it to exponential form with the circle that I've been using. But first I gotta get rid of this 6 that's hanging on the outside. So now I just have natural log of 5x equals 5. And now I can go ahead and set it up. So remember, this is natural log is just log base e. So base up to the 5th power equals 5x. E raised to the 5th power equals 5x. Isolating x, so divide both sides by 5. And I get x equals e to the 5th power divided by 5. So I'll check here to see what answer they want. Do they want a exact answer, or do they want an approximated answer, right? So I go up here and they're asking in the small blueprint for an exact answer. So I'm going to leave that e to the 5th as is, and that would be my answer. Let's check it. So natural log 5x, so it's being multiplied, right? So 5 times, we said that my x was e to the 5th over 5. I know that looks crazy, but we're just gonna, and you know, you can look at that and say, oh, but that's simplified because it's being multiplied by 5 and then divided by 5, but I would enter it in just as is into the original log. And then it does indeed equal 30. So I know I'm on the right track. So on this one, we're going to have to recall some of those properties that we learned about logarithms. In video 1, I explained a little bit more into detail why this would be x plus 6 to the 1/2. I'm getting the 2 from here. This is raised to the 1st power, so I would go through the slides just to see a little bit more detailed of a explanation for why we write it like that. All right, so I'm going to take this exponent and put it up front. Again, these are some of those properties that we learned, so you might have to go through some of the previous videos. Okay, remember I want that basic logarithmic form, so 1/2 hanging around out up front, it's got to go. I'm going to divide by 1/2, divide by 1/2, bring it up here. Now I have natural log of x plus 6 equals 2. Remember, natural log is just log with a base of e. I'm going to go ahead and write it out so we can see how that looks when we circle around. So base of e raised to the second power equals x plus 6. Base of e raised to the second power equals x plus 6. Okay, I'm going to subtract 6. Subtract 6. I get e squared minus 6 equals x. All right, let's check it in our calculator. So natural log of the square root and then our x was e squared minus 6. But then that was just our x, right? So it was x and then x plus 6. Okay. And that equals 1, so we're good. Okay, so notice here that we have 2 logs equal to 4, right? In order for us to apply what we've been doing, where we've been converting the logarithmic equation into an exponential equation, just writing it differently, right? It's same, just different expression of it. We have to be able to just have that 1 log. So I'm going to use my product rule to condense this. So remember, if I have the same basis for logs, then the values that I was taking the logs of will be multiplied inside. Okay, now that I have it in this form, I can say base of 3 raised to the 4th power equals 5x. Punch 3 to the 4th power into your calculator. We get 81 equals 5x. Divided by 5. Divided by 5. So I get x equals 81/5. That's a positive value, right? I have to remember x does not have to be a positive value necessarily, but the value that we're taking a log of has to. Since there's only x there, then yes, it would have to be a positive value. So that's what I'm getting. I'm going to plug it into my calculator. And we do get 4. Same approach on this problem. We see that we have 2 separate logs, and in order for us to approach it the same way that we've been approaching it, we would have to condense this to 1 log. So I'm going to write this a little bit bigger here. And the reason that I'm able to condense these logarithms is because they have the same base. Okay, and since there's addition between these 2 logs with the same base, I'm going to condense it down to 1 log, and then multiplication between the values that that we were taking the logs of. So foiling shows back up, right? It doesn't go away. Okay, so we would say same thing. You can FOIL inside here, or you can go ahead and write it in exponential form and then FOIL there. It's up to you. I'm going to go ahead and just show it in exponential form first. So 2 raised to the 3rd power. Let me make that a little bit smaller. 2 raised to the 3rd power equals whatever value we're taking the log of. So two cubed equals x minus 5 times x plus 2. Go ahead and FOIL that. You can also simplify on the left side. So 2 times 2 times 2 is 8. Then distribute x squared plus 2x. Distribute the second term. Minus 5x minus 10. Let's simplify. Have 8 equals x squared minus 3x. That came from 2x minus 5x minus 10. Remember, I'm solving for x. So I see I have a quadratic equation here because of that x squared. So I can get it in that standard quadratic form where I have x squared, ax squared plus bx plus c. So this needs to be moved because I need to set it equal to 0, right? And I'm actually going to put the 0 over here on the right side. I could leave it over here. So I didn't change anything. I just switched sides of where the 0 was on. Okay, so we can FOIL here. We can use the quadratic equation. You pick your poison, however you like to solve quadratic equations. I'm looking for 2 values that will multiply together to get negative 18, but add together to get negative 3. Okay, so negative 6 times positive 3 would give me negative 18. Add it together, it would give me negative 3. I'm going to set each one to 0. Solve for x. So I get x equals 6. And x equals negative 3. Okay. So I think that that's my solution set, but remember, I have to make sure that if I was to plug this in into the logs, that it would not give me a negative value altogether, right? So I have an x in here and an x in here. So let's try 6. 6 minus 5 would equal 1. I can take the log base 2 of 1, and then 6 plus 2, that would give me 8. So this would be equivalent to 8, and that works out, right? Okay, so 6 is definitely an answer. Let's try that with negative 3. Negative 3 minus 5. Sorry, that's really messy. Equals negative 8. So we can stop right there because it would have to be able to be plugged into every single part of the equation. Now, please note that it's not that x is equal to negative 3. So the negative 3 is not disqualifying it, like that value being negative. What's disqualifying it is when I plug it into the log, the overall value of what we're taking the log of is negative. So that's the issue, because earlier we had an answer where x was negative 16, but it worked out because it was negative 16 plus 20. So the overall value of what we were taking the log of was still positive. So we throw this one out, and my answer is only 6. Okay, same approach here. We're going to have to condense these. They both have the same base, so I'm able to do that. So log base 3, it's going to be the product of each of the values we were taking the log of. Once I have it condensed, I can write it in exponential form. 3 raised to the 5th power equals x plus 4 times x plus 22. Again, you can FOIL it while it's still in the log. That's up to you. I'm going to go ahead and simplify here. 3 to the 5th power, 243. I did not know that off the top of my head. I paused the video and punched it into the calculator. Going to FOIL here, so multiply that first term by each of the other terms. I get x squared plus 22x. Then take the second term and multiply by each of these terms. So plus 4x plus 88. I'm going to simplify this side. So simplifying the right side by combining linked terms. But then also getting it into that quadratic standard form. So setting it equal to 0. We're going to go up here. Okay, now we can factor. You can use the quadratic formula. It's up to you. With this, with these larger numbers, I'm just going to use the quadratic formula. So let me put that up here. Okay. If you're like wondering, what is this? I recommend that you go back to the previous videos where we covered the quadratic formula. It was a couple videos. So this would be my A, this would be my B, this would be my C. Just gonna plug it in. So negative B 26 plus or minus B squared minus 4AC over 2A. And then simplifying this, so I just put that entire part underneath the radical in the calculator, and then I found the square root of it. Okay, so I'm going to plug into the calculator negative 26 plus 36 divided by 2, and then negative 26 minus 36 divided by 2. Oops, I did. Let's see what we get. We get 5, and over here we get negative 31. Okay, so this is what I'm thinking my solutions are, right? But remember, I have to go back to the original equation and see if that makes this value all together in parentheses. I don't automatically throw out that negative 31 because if I had negative 31 plus 45, that would work out. So I plug in 5. 5 plus 4 would equal 9, so that works here. 5 plus 22, that would be 27, that works here. So 5 is definitely one of my values in the solution. Negative 31. Negative 31 plus 4, that would leave me in the negatives. Negative 31 plus 22, that would leave me in the negatives as well. As soon as it left me in the negatives for that first portion of the equation, I could throw it out because it would have to meet all in every place in the equation, right? So no on this one, but 5 is okay.